welcome back to part 2 of 3.1. In this lesson, we're going to look at limits at infinity. So, as x approaches infinity, which we would write like this, all that means is x becomes larger without bound. So it's going to keep getting larger and larger. Here, as x approaches negative infinity, means that x just becomes more and more negative without bound. Okay, let's look at an application, which you can pause the video to read this and then unpause when you're ready to review. Suppose a small pond normally contains 12 units of dissolved oxygen and a fixed volume of water. Suppose also that at time t equals 0, which is just your starting time, a quantity of organic waste is introduced into the pond, with the oxygen concentration t weeks later given by f of t equals 12t squared minus 15t plus 12 divided by t squared plus 1. As time goes on, what will be the ultimate concentration of oxygen? Will it return to 12 units? So let's take a look here and plug in some values and see what's going on. So let's say time is 2 weeks. Let's look at what the units of oxygen would be. So I would just simply plug in 2 for t, and I would get the following. And if I simplify that, I'm going to get 6 units of oxygen. So that would be after 2 weeks. That would be the ultimate concentration of oxygen. Okay, how about after 4 weeks? If I simplify that, I'm going to get somewhere around 8.5 units of oxygen. So one of the things we're noticing here is that time goes on, we can see that the unit of oxygen is getting greater, but does it increase without bound, or does it eventually approach something? So let's go to our calculator and let's go to our table and see. So we're going to type in here. We're going to get rid of whatever's in y equals, and we're going to plug this in. And there is no t on the calculator. We're just going to use x. So you're going to have 12 and then x squared minus 15 times x plus 12, and then divided by x squared plus 1. Okay, hit enter. My table, we're assuming, is already set up. If it's not, you want to go to second window and make sure your independent variable says ask. And then we're going to go to second graph, which is going to take us to the table. And I'm going to delete these values, and we're going to plug in some more values. So we can check the answers. We plugged in 2, we got 6. We plugged in 4, we got 8.5, right? How about 10, or 100, or 1,000, or 10,000? As you can see here, as x is approaching infinity, f of x, or y, is getting really close to 12 units, right? Now, is it ever going to be exactly 12? If we were to type in another value, right? Like put as many zeros as you want, eventually the calculator is going to round it to 12, but that's only because it doesn't have enough space to put the decimal equivalent in there. It's not going to be 12 ever exactly, okay? And there will be a horizontal asymptote there. You can tell if we look at the graph. So if you take a look at this graph, and we may have to change our window, so we're gonna have to change it to the default window, which is -10, +10, and then maybe -10, and we'll do 20 for this one. And count by ones. Okay, now I'll try graphing it. And you're going to see that there is a horizontal asymptote at y equals 12. Okay, and we're looking from the right side, right? Because we're not going to have a negative. So if you go back in and just type in -12, you can see it more clearly if it graphs it, or sorry, +12. Okay, and you can see that the function is going to get really close to the red line, but it's not actually going to go through it. Okay, and you can of course change the window. Again, you can make your x max 100, and let's change our x min to 0 and our y min to 0. So we're not actually going to look at negatives here since we're dealing with oxygen concentration, right? Can't have negative. So now go to graph and you can see that it's never actually going to intersect with that horizontal asymptote. So one thing we can kind of assume here is that limits at infinity, and that could be positive or negative, if they exist, correspond to horizontal asymptotes of the graph of the function. So in general, here's a rule that you can use for finding horizontal asymptotes. For any positive real number, n we'll call it, the limit as x approaches infinity of 1 over x to the n is going to equal 0. And the limit as x approaches negative infinity of 1 over x to the n also equals 0. Let's see how we can apply this. And I apologize, there's not a ton of room for that, but we'll do our best. So what we're going to do is we're going to evaluate the numerator and denominator, and we're going to take the largest power of the variable that appears in the denominator, and then we're going to divide everything by it, and then use our results, okay? So we're going to evaluate the numerator and denominator by dividing each term by the largest power that appears in the denominator. And then simplify. Okay, so here's our function. We're going to evaluate it as t approaches infinity of 12t squared minus 15t plus 12 over t squared plus 1. So my highest power that appears in the denominator is t squared. So I'm going to divide each of these terms by t squared. So you're going to have the limit as t approaches infinity, and we're just going to take each of our terms and divide them by t squared. Now, the more you do this, the less work you're going to have to do for it, okay, because you can do it in your head. But I'm going to write it all out since it's the first time. So what we're going to do now is we're going to go through and we're going to simplify. And what I'm left with here, the t squareds are just going to cancel. So I'm just left with 12. In the next term, you're going to have minus 15. Only one of the t's will cancel. You'll still be left with 1. So we're going to be left with 15 times 1 over t. And then I have plus 12 times 1 over t squared. And then I'm going to divide that by 1 plus 1 over t squared. Now we can use the limit rules we learned in the last video. So now I'm going to split this up. I'm going to have the limit as t approaches infinity of 12 minus the limit as t approaches infinity of 15 times 1 over t plus the limit as t approaches infinity of 12 times 1 over t squared, and then all over the limit as t approaches infinity of 1 plus the limit as t approaches infinity of 1 over t squared. And if you'll recall, here you're taking the limit of a constant, so that's just going to be 12. Here you're taking the limit of a constant, so that's just going to be 15 times the limit as t approaches infinity of 1 over t. And then likewise, 12 times the limit as t approaches infinity of 1 over t squared, all over the limit of 1 is just 1 plus, and then the limit as t approaches infinity of 1 over t squared. Now, if you'll remember, this little piece and this little piece and this little piece, they're all going to equal 0. So we're just going to replace all of those with zeros. And we're going to have 12 minus 15 times 0 plus 12 times 0 over 1 plus 0. Those little pieces go away, and as you can see, your final answer is 12, which is what we noticed by looking at the table on the calculator, by looking at the graph, and then by plugging in values. So at this point, you can pause the video, and there's 4 practice problems here that you can try to evaluate for more practice. Okay, I'll do one of these with you. So if we take a look at the first example, we want to find the limit, and we're looking at the limit as x approaches infinity. So we're going to take each of our terms in the numerator and denominator. We're going to divide by the highest power that's in the denominator, which would be x. So all I'm going to do is take each term and divide it by x. Then I'm going to go through and I'm going to simplify. So I have the limit as x approaches infinity of 8 plus 6 times 1 over x over 3 minus 1 over x. And then we're going to apply our limit rules. So we know the limit of 8 is just 8. And then I have 6 times the limit as x approaches infinity of 1 over x. And then I have the limit of 3 minus 1 times the limit as x approaches infinity of 1 over x. And these will just turn to 0. So they're just going to go away. So really what you're left with is 8 plus 0 over 3 minus 0, which is just 8/3. And that's your final answer. So at the end here, we have a little recap of finding limits at infinity. Okay, take the time to read through, but it's basically what I wrote down earlier. And then the next lesson, we're going to look at continuity. Hope you all have a great day. If you have any questions, please reach out.